Shinde. Let me briefly introduce you to Dr. S.J. Shinde. Working in the field of environmental engineering for more than 20 years, Dr. Sunil Shinde is presently working as an assistant professor in the civil engineering department at DIEMS Chhatrapati Sambhajinagar. He is a strong engineering professional, having obtained his ME in WRE and PhD in civil engineering. As an educator, he has more than 20 years of teaching career. An accomplished researcher with more than 15 publications to his credit and 2 books published. He has actively participated in more than 25 short-term training programs and AICTE sponsored FDPs organized by various well-known technical institutes. He is working on ongoing research project titled Composite Grey Water Treatment System for Rural Household from Deep-2. In addition to his roles as an educator and researcher, he has also gathered extensive administrative experience. He has also served in various statutory authorities, such as member of Board of Studies and technical committees. He has been an executive council member of IVA for more than 8 years and has served as the chairman IVA Aurangabad Center. He is also an active member of 3 professional bodies. Now, I request Dr. G.R. Gande sir to please felicitate Dr. S.G. Shinde sir. I'm sure this session is going to be a very fruitful one, and all the applicabilities will be explained in this session. I now request Dr. Shinde sir to please commence the session.
Thank you very much, Ramesh ma'am, for giving my nice introduction. So I am faculty from Civil Engineering Department. Kindly bear me for 2.5 years. So my title of my presentation is Assessment of Groundwater Contamination using GIS and Remote Sensing. So I am a little bit experienced regarding GIS and remote sensing and how you can assess river water and how river water is going to impact on groundwater. That aspect I will cover, and whatever the contamination occur in groundwater, we can present it with the help of GIS and remote sensing. It's the best topic that can be you can use also during your project work or dissertation or for PhD work. So it's a very nice topic. I will cover introduction. In introduction, I will focus on river water. So what are the major river in India? That I will cover. Then I will cover whatever the major river in Maharashtra. Then I will come towards the Aurangabad, major river in Aurangabad, tributary of the Godavari. Then groundwater resources present in India, dug well, bore well, that aspect I will cover. Then sources of contamination, sources of pollution of river water and groundwater, that aspect I will cover. And how we can present this contaminated river water, then groundwater with the help of GIS, with the help of few important tools or plugins by using ArcGIS 10.1. that I use. So that aspect I will cover, and then conclusion. So as we know that river and groundwater are the major source of water for domestic purpose. In urban area, we need water for domestic purpose. So domestic purpose, domestic demand of Aurangabad urban area, it is approximately 150 MLD. So whatever the water we required for drinking, bathing, washing, gardening, sanitation, that water is given by municipal corporation with the help of MGP, Maharashtra Jivan Pradhikar. So for that, water supply system is available in each and every city, each and every rural area. Second part, irrigation. So our Jaipur dam is a multi-purpose dam. It is having height 41 meter, length 10 kilometer. Its catchment area is more than 2,600 hectare. So here, whatever the water is available at the upstream side of Jaipur dam, that is a multi-purpose dam. We are using that water for domestic purpose. So water supply system intake structure is constructed at the upstream side of dam. Intake structure connected to WTP. WTP is helping us to convey water up to the ESR. In Aurangabad, total 64 ESR. With the help of ESR, this MJP and municipal corporation is fulfilling the water domestic water demand. Second part, irrigation. So your Jaipur dam is having two canal, RBC and LBC. One is going up to 232 kilometers, another one is going to 128 kilometers. So it's an irrigation demand. So that purpose also we are using. So we are using water, that river water and groundwater to fulfill the demand of irrigation. So we need water for irrigation purpose. Irrigation means artificial application of the water to the crop. So when water is rainfall is not available, in a rainy season we are getting water. After rainy season, whatever the water required, it is fulfilled by the groundwater with the help of groundwater and river water, which is stored at the upstream side of dam. That is called reservoir. So that water we are using for irrigation purpose. We are supplying water to the farmer for the growing of cereal crop. Cereal, jawar, bajra, that is a cereal crop. Then horticulture crop, pomegranate, custard apple. For that purpose also we are using irrigation water. Then vegetable crop, we require water. Fodder crop, for cattle we need fodder crop. So for that purpose we are using irrigation water. So major source in rural area, groundwater. In major source. And river water that we are storing at the upstream side with the help of command area development, with the help of RBC, with the help of LBC. RBC and LBC are connected with the distributor are connected with the field channel. With the help of field channel, we are supplying water to the farmer to grow the crop, which is very important because India is agriculture country. Okay. Third part, we are using that water, whatever the water, each and every city. That is you take example of Nashik city, it is located on the bank of Godavari River. You take Pune city, it is located on the bank of Mulanmutha River. You take example of Vaitarna, on the Vaitarna, that Panvel city is located. So we are using that water for industrial purpose. So industrial in Aurangabad region is surrounded by four major industries. One is Vadud MIDC, Chandra MIDC, Chikatana MIDC, Chitapa MIDC. So we are using that water. So it's very important what happened with the water. So our southern part of India is covered by Indian Ocean. One is at the west, Arabian Sea is there, at the east, Bay of Bengal. So major river flowing, Yamuna, Gangotri, then Gomti, these all rivers are flowing towards the Bay of Bengal. Then you take example of Godavari, it is flowing towards the Bay of Bengal. Then another Tapi is flowing towards the Arabian Sea. So these are the major rivers present in India. So your India is considered a water-rich country. We are having water, good water in the river water, good water in groundwater. It's a water-rich country. The total catchment, so in India, total 400 rivers, major and median and minor rivers are present. So major source, good water is available in the river water. Second thing, around 80% of India's water flows to the major river, and 15% water flows to the minor river. Minor, Sukna, then Kham river. These are the minor river. And third one is, it is a water-rich country. Water-rich country. Second, groundwater availability. In India's total annual groundwater availability is 399 billion cubic meter, BCM. This much of water is available, groundwater. With the help of dug well, with the help of bore well, that water we are using in India. In Maharashtra, in each and every state, we are using that. Groundwater extraction near about 239.16 BCM, billion cubic meter. That much of water is available in the groundwater, below the earth's surface. That water is very helpful. See what government of Maharashtra, government of India, they are doing. Huge budget is assigning for WTP. Huge budget is assigned for water supply system. In other way, if they are trying to replenish, recharge this groundwater, there is no need to install all this type of water supply system. If we are conserving groundwater system, and this near about rainfall contribution, 67% of India's annual groundwater resources. So whatever the groundwater is getting recharged, it is the recharge will be from the rainfalls. In Aurangabad, annual rainfall is 600 to 700. In Nashik, annual rainfall is more than 4,000 mm. In Mumbai, as ma'am said, 2,500 annual rainfall mm. It is an mm. So it is a good source of water. Then dug well quantity in India is 82,78,425. This much of dug wells are present. So this is the source of groundwater. So I will discuss now major river in India. So major river in India, rivers flowing into Bay of Bengal. Each and every river will be the case study for the student, faculty, for their research work, for their project work. So Meghna River, it flows from through the Meghalaya, Manipur, Mizoram, Nagaland, Tripura, Barak, all these states it is flowing. It is having total length 946 kilometers and it flows, it fall in a Bay of Bengal. Second river is Ganga River. It is a perennial river. It flows through major city Varanasi, Patna, Haridwar, Rishikesh, Kanpur, Allahabad, Lucknow, Kolkata, Agra, Meerut. All these major cities are located on the bank of Ganga River. And Ganga River now is becoming as a polluted river. Why? Because of all domestic wastewater which is generated by the community which is living in this city. Most of the wastewater without any treatment, they are releasing that wastewater in a river water. That is why Ganga is polluted. So government of India started Namami Ganga, that is to clean Ganga. For so many STP they have constructed on the bank of Ganga River to treat wastewater. After treatment, they can release wastewater in a river water. But that project is going on now. Third one, Godavari River. It is in Maharashtra. It is also perennial river. The Godavari River, origin of Godavari River is Trambakeshwar. It passes through five states, Maharashtra, Andhra Pradesh, Odisha, Madhya Pradesh, Karnataka. And its length is approximately 1,465 kilometers. It's a huge length, flow length is there. And it's having catchment area, basin area, 3,12,812 kilometers. This much of basin area. Through the basin, water get infiltrate, percolate, and trying to recharge groundwater. That is the major part. Third one is Krishna River. It is also in Maharashtra. It passes through Maharashtra, Karnataka, Andhra Pradesh. Its length of this Krishna River is up to 1,400 kilometers. And its basin area 2,58,948. Why I am saying this catchment area, basin area. When water is flowing to the basin, water is getting infiltrate, percolate, and trying to recharge groundwater. If that water is getting polluted, what will happen? Automatically, it will affect groundwater. That's why in GIS and remote sensing can be applicable for each and every river. So people from IIT Delhi, people from IIT Madras, people from IIT Mumbai, all they are working by understanding the river condition, by understanding the catchment area condition, by understanding the groundwater. So GIS and remote sensing is good scope to work on this type of problem. This is the problem. Problem is it is getting polluted. Kaveri River. So Kaveri River passes through Karnataka and Tamil Nadu. Major city located on the Kaveri River, Mandya, Bangalore, Mysore. So length of Kaveri River is 800 kilometers. So many tributaries are connected to this Kaveri River. Again, on the bank of tributary, small cities are located. Then these are the river are flowing towards the Arabian Sea in the Sindhu River, Indus River. So Indus River passes through Pakistan, India, China, Afghanistan. So length of this river is 1,114 kilometers. The basin area is 3,21,000. Narmada River, origin of Narmada River is Himalaya. So length of this Narmada River 98. Length is not available. Catchment area is available 98,796 square kilometers. This huge catchment area is available. Tapi River, it is between Maharashtra and Gujarat. On the bank of Tapi River, Surat is located. Surat. and so many tributaries are connected to Tapi River. So because of industrial areas in Tapi River, so Surat industrial area is on the Surat, so Tapi River is getting polluted. So and Sabarmati River. Sabarmati River, it is having length 300 kilometer. Its catchment area, so basin area is 21,674 square kilometer. So this is about the India's river. Then major rivers in Maharashtra, Girna River. So here in Jalgaon, Girna River is there, flowing towards the Arabian Sea. Godavari River flowing towards the Bay of Bengal. Mandra River, Koyna River. On the Koyna River, Koyna Dam is constructed. Bhima River, Tapi River. All these major rivers fulfilling the demand of domestic demand of urban area and rural area. How it will? Godavari River is having tributary Pravra, Purna, Mandra. On each and every tributary, small cities are located. Krishna River, on the Krishna River, these are the tributary Ghat Prabha, Mal Prabha, Bhima, Tungabhadra, Musi, and total it passes through the three states Maharashtra, Karnataka, Andhra Pradesh, and its basin area is 2,58,948. And this is the basin area, catchment area of Krishna River, Tapi River. This is the catchment area of Tapi River, and this is the major dam, which is a good source of surface water for the fulfill the demand of urban area and rural area. Koyna Dam, Sardar Sarovar, Bakra Dam, Tehri Dam, Nagaj Dam, Hirakund Dam, Rihana Dam, Mita Dam. Each and every river we are using by constructing dam, we are using that water for fulfill the demand of urban area and rural area. So these are the major dams in Maharashtra: Mula Dam, Jackwar Dam, Darna Dam, Wilson Dam. More than 500 small and medium dams are present. All these dams are constructed by Government of Maharashtra, Government of India to fulfill the demand, domestic demand and irrigation demand of the community which is living in a urban area. So what happened with all these sources? So these are the paper cutting I have collected. Pavitra Godavari Nadiche Gatarikar. So these are the condition of river water. See here, near about 380 mld of wastewater we are releasing in a river water through the Nasik Municipal Corporation. This is the existing condition of river water. So we have made this river in a wastewater channel. Near about 361 villages, those from the Trimbak, Nashik, Nifad, those who are using that river water for irrigation purpose, they are using that polluted river water. And because of that, their soil is getting infertile. And also it is affecting groundwater. Second thing, in Mumbai, more than 1,450 mld, this much of wastewater created by, born by community which is living in Mumbai area, they are using their wastewater in ocean. And this is the existing condition of ocean, Arabian Sea. Next, Mulan Muta River. On the bank of Mulan Muta River, Khadakwasa Dam is constructed on the bank of Mulan Muta River. And Khadakwasa Dam, so on the bank of this Mulan Muta River, Pune city is located. So here, Pune population is 52 lakhs. More than 750 mld of wastewater, the people, community which is living in Pune area, they are releasing that wastewater without any treatment in a river water. For near about 9 STPs are there, but because of improper maintenance and operation, the treatment of wastewater is not getting properly. That's why domestic wastewater without any treatment they are releasing. This is the existing condition of Mulan Muta River. See, Pune population 52 lakhs, more than 750 mld of wastewater, it is getting released in Mulan Muta River. Near about 40 efficiency of STP is only 40%. That is also a major problem. STP are not maintained and operate properly. Remaining untreated domestic wastewater disposed in a river water directly. This is the fact. In each and every city, this is the fact. That's why river water is getting polluted. About 100 villages from farmers are using river water for irrigating 76,981 hectares. And these people are facing the problem because of polluted river water. Whatever the water they are using for irrigation water, their soil is getting polluted. Again, during irrigation, the farmers are coming in contact with the water and they are facing the problem of skin disease. And feet are also getting problem. That is a fact. Solapur city further dam is Akluz Dam, which is constructed on the Mulan Muta River. Akluz Dam is also getting polluted river water. So a lot of people are also in that wastewater, in that river water, and that is also contaminated. So industrial wastewater, that is about domestic wastewater. And industrial wastewater, so here the river Ganga from Haridwar to Kolkata is regarded as one unending sewer, which is fit only to carry urban liquid waste, half-burned dead body. Then pesticide, insecticide are getting released in the wastewater. That is a major reason of river water pollution of Ganga. Near about 312 industrial units are located on the bank of Ganga River, and they are directly releasing their wastewater in that Ganga River. Only doesn't have effluent formality. They are implemented install ETP, effluent treatment plant. Then 27 cities contribute 902 million liter of wastewater in a Ganga River. So near about 27 cities are located on the bank of Ganga River. So river water is getting polluted. So this is current cutting I have collected from 3rd January in this month. So this statement saying that Wardha, Yavatmal, Nanded, Bid, these are the city groundwater is contaminated due to nitrate concentration. If nitrate concentration in a river water, groundwater, it is more than 45 mg per liter, that water is called contaminated. And nitrate concentration gives the indication that the decomposition process, whatever the organic matter present in the river water, groundwater, river water, the decomposition process is going on. So it is nitrate is giving indication that decomposition process is going on. So nitrate, and because of nitrate, people or women can face blue baby disease. Blue baby disease hoto. And it may damage your kidney, it may so many side effects will be there for the human being. So nitrate concentration and BOD will be more than 100 mg per liter. That is a major reason. So for the condition of river water and groundwater. Second thing, in India, near about 707 districts, as per census, 707 districts are present. Near about 4,000 small, medium cities, taluka level cities are present, and total 6,40,867 villages are present in India. And each and every village, each and every city, each and every taluka are trying, they are releasing their domestic wastewater in river water. Anyhow, second thing in Maharashtra, total 41 villages, 41,000 villages are present. Near about small and medium talukas, 378 urban areas present, and 36 districts are present. And each and every district or city is located on the bank of any other river or tributary. Aurangabad, and second thing, Aurangabad is having 9 talukas: Aurangabad, Kannad, Soygaon, Sillod, Fulambri, Khultabad, Vaizapur, Gangapur. All these are having some percolation tank, river water will be the source of water for to fulfill the demand of domestic wastewater. Second, though we are having so many laws, one is Water Prevention and Control Act 1974. So MPCB has published so many laws. One law is Water Prevention and Control Pollution Act 1974, Environment Protection Act 1986. Then MOEF is working to stop the pollution. Then so many IS codes are there for the sewage effluent disposal in river water by dilution method, industrial effluent disposal in river water by dilution method, IS 2490 1974, IS 47964 1973. Then also this type of activity is done. It is called anthropogenic activity, man-made activity. Man-made activity is the major reason for the river water pollution and groundwater pollution. So here I have prepared one flow chart. See here, in urban area, rural area, reservoir and borewell is the source to fulfill the demand of domestic wastewater. With help of water supply system, they are trying to fulfill the demand of domestic demand, industrial demand. So people using for drinking water, bathing purpose, for gardening purpose, industry are using water for manufacturing process. After using, they are not treating water, or they are doing formality of treatment of the water. And untreated water, they are disposing directly with the help of sewerage system. In urban area, house sewer, branch sewer, trunk sewer, separate sewerage system, they combine sewerage system. That sewerage system is helping us to convey wastewater. That wastewater, we are trying to treat it, but without any treatment, that they are releasing that water in a river basin, or maybe ocean in there, then they are using that water in the ocean, or otherwise they will dispose that water by using land disposal method. So because of all these reasons, your river water and groundwater is getting contaminated. So this flowchart will be give you brief idea about this pollution. So more we can conclude that most of the river are polluted by direct discharge of industrial effluent. What is MIDC, Chandra MIDC? They are directly discharge their water in a small channel, or directly they are created injected well. So they are injecting that water in a river water. So these are the sources of water pollution. Domestic water pollution, grey water. Grey water, whatever the water we are releasing from the bathroom, washing places, it is called grey water. Whatever the water we are releasing from the toilet, it is called black water. Combination of grey water and black water is called sewage. So that's why sewerage system. It's helping us to convey wastewater from house to the disposal place. Industrial water pollution. So your industry area is covered by so many industries: steel industry, thermal industry, pharma industry, automobile industry, the fertilizer industry, sugar industry. Each and every industry during processing they are using water, and after using water with help of BTP they have to treat it. But without any treatment, they are releasing their wastewater directly in a groundwater or river water. That is a major reason of the pollution. Agriculture water. So farmers are using fertilizer. So urea, diammonium phosphate. So because of huge use of fertilizer, that fertilizer may come in as coming contact with soil during irrigation. That fertilizer getting mixed with the water, and due to infiltration percolation, that fertilizer coming in contact with the groundwater. Also, that is a source of contamination. So groundwater may consist nitrogen, phosphorus. So many pollutants may be present in a groundwater. It may be the agriculture water pollution. Solid waste pollution. So Naregaon in Aurangabad, Naregaon is a one dumping ground, and so many places Aurangabad municipal corporation is dumping their solid waste. And because of rainfall, because of physical summer condition, because of that, and during rainfall, whatever the water is coming with the coming in contact with solid waste, getting leaching, infiltration. That is also major source of contamination. Shipping water pollution, ocean ships are going to transport oil, raw material. Because of accident, that oil maybe get mixed with the ocean. That's one type of pollution. And radioactive water pollution. So Dr. Homi Baba Atomic Center at Tarapur. The people which are living in the Khade region, they're also facing the problem of pollution because of atomic plant at Tarapur. So these are the major reasons of a river water pollution, river water, groundwater pollution, and ocean water pollution. So here, domestic wastewater pollution, homes and commercial places are the sources of water pollution. Then approximately 70% of water pollution is done by only domestic wastewater, and remaining covered by the industrial wastewater. So Bombay City alone generate 3,500 tons of garbage on daily basis. So it is very hard to dispose that garbage. Again, that is a problem of maintenance or dispose of garbage. That is also one source of pollution. So if we treat properly this wastewater, it can be good source of fertilizer. Otherwise, if we treat properly, if we maintain STP properly, if we are treating wastewater properly, that treated wastewater can be used for the construction purpose or irrigation purpose. If we maintain the standards as per norms, we can use that water. It's a good source of fertilizer also. So industrial water pollution, it should consist BOD load more than 500 mg per liter. Whatever the wastewater released from the sugar industry, it is having BOD load more than 5,000 mg per liter. 5,000. So this is existing condition. So this is a source of pollution. So in industrial water pollution, it consists industrial wastewater consists of organic substance, inorganic substance, acid, alkali, toxic substance. So all these industry are releasing wastewater consists this type of pollutant, and our Aurangabad is surrounded by major industry. Same Pune is surrounded by that Shikrapur and MIDC. Nashik is surrounded by so many industrial centers. So each and every city is facing this type of problem. Chlorine concentration, it is also a major problem in so many rivers. So because of chlorine, plankton and fish are getting affected in river water. So river comb in Madras, in river comb in sample testing, it is observed that 900 mg per liter iron concentration observed in comb river in Madras. So because of this industrial wastewater, there is 275 mg per liter of lead concentration in river water. Then nickel concentration 32 mg. This is the sample tested by the some laboratory, and I collected this detail from the one referred research paper. So this is the fact. So one MC Mehta is well-known advocate. He is trying to stop this type of activity. He has filed so many cases against municipal corporation and industry. One case action against tannery industry polluting the river Ganga, action against municipal party and that MPs, municipal party and that industry also done because of this MC method. So this type of people are there, but there are few people only. So I refer some paper that will see assessment of groundwater quality and its suitability for drinking water. So in this paper, that author work on electric conductivity, pH, TDS, sodium, potassium, calcium, magnesium. So he has observed 31 groundwater sample. He found that water is polluted. Second thing, he also assessment of groundwater contamination by using GIS. So GIS can be used to present which are the areas. So this is the fact. He has investigated groundwater contamination. He has found special relationship among groundwater quality, topography, geology, land use, and pollution sources. He worked on bicarbonate, and silicon. He also worked on chloride, nitrate. These are the pollutants he observed. Second, groundwater contamination by heavy metal in water resources in Sierra Leone. So he has also assessed heavy metals, arsenic, cadmium, chromium. These are the pollutants he assessed. So he found that these are the pollutants are present and beyond certain limit. So this is the sources of pollutant. These are the facts. The referred journals are there, so you can refer us. So one paper, assessment of groundwater contamination by nitrate leaching from intensive vegetable cultivation using geophysical information system. So 90% of water samples showed nitrate concentration. So this type of conclusion we find. Mapping of groundwater contamination is also one good paper you can refer. So I will focus on our case study, which I have worked during my research work. So I have selected a few water sample parameter, pH, TDS, electric conductivity, sulfate, nitrate, calcium, magnesium, sodium, chloride, potash, bicarbonate, lead, chromium, cadmium, zinc, copper. So how they are, what is the concentration of this pollutant in a river water and groundwater? So I assessed with help of some index, chemical index, sodium adsorption ratio, SAR index, Kelly's index, percent sodium. So these are the index will instruct us. So beyond certain limit, we can say river water is polluted. We can say groundwater is polluted. So after getting the assessed water quality parameter, I have prepared some map, groundwater quality map for this my particular study. Also, I work on a vertical electrical sounding. So groundwater, profile of soil. So how we can relate that also I covered. So this is my case study area. The study area covers specific region of Aurangabad and Gangapur area. So I have collected near about 11 river water sample from Kham River. Kham River is a tributary of Godavari River. It's coming from Jatwada, going towards the Godavari River. So it is having 35-kilometer length. So in that I have collected some river water sample. Near about 54 groundwater sample I have assessed. 27 at the right side, 27 at the left side. So this is the Kham River from Jatwada towards the Banewadi, Golwadi, Vadadgaon, then Patoda, Naiga, Vadus. So these are the 7 villages I have selected, and 27 well at the right side, 27 at the left side. So I have assessed sample and I understood that groundwater is getting affected because of polluted river water. So these are the sample points. So these are the villages. Total area hectare, cultivable land in that area. So this water, this cultivable land, for this cultivable land, farmers are using water. And I have visited that field, I observed, I discussed with the farmer, I have performed net planning, I have performed base planning survey, collection of river water data, collection of soil data, collection of depth of river, groundwater, pumping test data. So how many time required to recharge the groundwater, that's all details I have observed. खाम नदीमध्ये 249 ठिकाणी सोडले जाते सांडपाणी. So this is some facts I have collected for my study purpose. So many person they are damaging natural sources also. Kalimali Sarovarat drainage Salim Ali, Dr. Salim Ali, here, Dr. Salim Ali, he's called as a birdman in India. By his name, the Salim Ali Lake is there. So many people which are living beside the Salim Ali, they are leaving their wastewater in this Salim Ali. Because of that, Salim Ali Lake is giving bad smell. If the river water is giving bad smell, it gives the indication of water is polluted. So Vadgaon and Pasar Talao Madre Kachra depots. So people are dumping their waste in a percolation tank. So our India, Aurangabad, Maharashtra, Aurangabad is surrounded by, my study area is surrounded by this MIDC, Shendra MIDC, Thana, Vadus, railway station MIDC. Shendra is covered, Shendra MIDC is covered, 600 hectares. So many industries are located in Shendra. In Vadus, 1,520 recorded industries. More than 3,000 industries are present in Vadus MIDC. Most of the industry, they are releasing their wastewater in a groundwater by using injected well. That is the fact. So many groundwater sample I observed that coming, whatever the sample, water coming to the hand pump, it is having gray color and black color. So it gives the indication of water is polluted because of that injection well. So railway station MIDC, it is beside our Deogiri. So it's oldest MIDC which is present here. So I observed that the people from the which are living on the Kham River. So I said that Kham River is coming from Jatwada to Godavari. So people, farmers which are living on the bank of this Kham River, they are pumping this river water, and that river water is a source of disposal of wastewater. So people, community which are living in Aurangabad, whatever the water passing through the house sewer, street sewer, branch sewer, that is we are disposing in a river water. And that river water which is polluted, which is flowing with the wastewater, domestic wastewater, that water is pumped by this farmer and using for irrigation. This is the challenge. The farmer is using that water. And because of what happening, water is not getting infiltrate in the soil. This foam is there. So it gives the indication of hardness water. The phase it gives the indication of presence of gray water, hardness, calcium carbonate, calcium bicarbonate. So this is, and because of that, your soil is getting infertile. Irrigated water was not easily getting infiltrated through the soil. So I stay there for half an hour, 1 hour, water will not getting. As though the saturation capacity is completed, but because of that, this type of parameter is not getting infiltrated in the soil. Automatically, it will affect the fertility of the soil. So many farmer has come their cow dung on the bank of Kham River. So this heap is a huge source of nitrate. So your cow dung is a huge source of, it's agriculture based, a huge source of nitrate, other parameters also. And because of the rainy season, if water is coming in contact with this heap, automatically the pollutants will get leached in a river water. As river water is having high concentration of nitrate, automatically it will affect the groundwater. So this is the existing condition. This is one image which I have collected during summer season. So this is the foam. Because of that, gray water is giving indication of presence of soap and your washing powder or other thing. So this is the indication water is polluted. So I have selected this parameter. So each and every parameter creating the problem, gives salinity hazard, root zone area is getting affected, water absorption capacity is getting affected because of high electric conductivity. Electric conductivity depend upon concentration of sodium, calcium, magnesium concentration in a river water and groundwater. Same with the TDS. So it is affecting directly gastrointestinal irritation. Sodium, TDS, sodium concentration is much more, it directly affect to the permeability. So whatever the water is passing through the soil, up to 10 centimeter, it is called infiltration. Because after that, it's called percolation, infiltration, percolation, and directly it is affecting the permeability of the soil. As permeability getting affected, automatically groundwater recharge will get affected. So this is the sodium create much more problem, and sodium is present in a domestic wastewater, also industrial wastewater. Calcium, magnesium, all these are creating the problem in soil. Chloride concentration, because of chloride, if chloride concentration is much more in river water, and that water we are using for irrigation purpose. So roots consume that chloride, and because of that, they are facing the problem of leaf burn, leaf necrosis. So these are the diseases occur in the plants. Then sulfate concentration, if sulfate concentration is there and that water is consumed by human being or animal, they are facing the problem of gastrointestinal. Okay. So this is our lead. Also, it is affecting to the human health. All these parameters are selected to understand the concentration, how they are getting affected on a plant. Cadmium, SAR, so sodium adsorption ratio. The formula for SAR: sodium divided by concentration of sodium divided by square root of calcium magnesium by 2. So SAR between 1 to 10, good water. 10 to 18, medium good water. Above 18 and above 26 is called not suitable for the irrigation. It's a best way to indicate the water is polluted or not. Percent sodium is having some formula, Gillis index, then the magnesium ratio is all you can. So I have used this methodology. Collection of river water and groundwater sample. I have collected 11 river water sample. I have collected 54 groundwater sample during pre-monsoon. पाऊस पडायच्या आधी. After post-monsoon, पाऊस पडल्यानंतर. At the both time I have collected sample and I have assessed, and based on that I have prepared some conclusion. So this is methodology. I refer IS 1164/1986. River and groundwater sample testing I did. So these are the parameters I have selected. I use some specific standard to assess the sample. I use topo sheet, DAM map, satellite image, Landsat image. I use topo sheet 47.5 that topo sheet I use. I did delineation of my study area. I created buffer zone 1.5 kilometer at both the side, and I use GPS Garmin instrument to locate the groundwater dug wells. Then I prepared some maps, groundwater quality showing maps for my study area. So I already mentioned. So this is my study area. So this is Garmin instrument. So because Aniket sir, that Garmin instrument we are using, that Garmin instrument I collected lat long for each and every dug well. So this is the in this way I have collected the diameter of dug well, depth of dug well, profile of dug well. I have prepared one form, collected all details. With the help of farmer, I have collected pumping test data, किती वेळात ती रिकामी होते, पुन्हा किती वेळेस भरते, किती वेळेस तुमची मोटर चालते. In this way, I have collected this detail. So this is the one table which gives how many sample pre-monsoon sea. Groundwater location at left, groundwater location at right, river water sample, pre-monsoon, post-monsoon, pre-monsoon 7, post-monsoon 7, pre-monsoon 10. In Golwadi, 20 sample I have collected. In Vadajod, 42 sample I have collected. In Patoda, 14 sample. In Naigaon, 26 sample. So sample collected, sample analysis I did in government engineering laboratory. This laboratory is available. Atomic absorption spectrophotometer, one instrument is was available. With the help of one lab assistant, I have performed all these laboratories. I found that water is polluted. How it is polluted and how we can present with the help of GIS, I will show you. Where you have performed this? In government engineering environment lab. Dika. College. So this all Banewadi left side well one that long depth of water. All this I have collected. All this I have collected. Then sample location, Kham River Basin, sample location. From this place I have collected pre-monsoon sample, post-monsoon sample, that type of dug well location. Then these are the laboratory work. So I have sample, collected sample is AF, atomic absorption spectrophotometer. So nitrate concentrations, cadmium, chromium, lead, this type of parameter I assess with the help of spectrophotometer. So GIS is used to present polluted area. So these are the topo sheet. Then I have prepared details in Excel file. That Excel file I have connected with the ArcGIS tool, and I have prepared some map. I will show it. Data discussion. So this is river water pollution, pre-monsoon and post-monsoon. pH variation in river water. You can show with the help of this type of graphical presentation. So all these river water sample. This is a classification of river water sample in relation to salinity and sodium hazard with the help of USSL during pre-monsoon. United States State Salinity Laboratory. One graph is there. With the help of that, you can present water is polluted or not. US Salinity Laboratory. So this one method we can say that water is polluted or not. C4S4. So it is highly polluted water. So this one is Wilcox diagram. It's also one type of indication presentation scheme. So here I want to show how I have presented these details here. Groundwater contamination. So your TDS concentration, if it is more than 2000 mg per liter in groundwater, so these are the well 1, 2, 3, 4, 5. These are the well which are collected sample is giving concentration more than 2000 mg per liter. So GIS is helping us for the presentation, which area is getting contaminated because of river water. So river water is impacting groundwater. So each and in this way, I have prepared TDS concentration, chloride concentration, the nitrate concentration. If it is more than 45 mg per liter, or nitrate concentration I am found. So in so many dug wells. So these are the location of dug wells. You can connect Excel file with the help of lat long. Automatically it coming that near to the river like. So this is the concentration of nitrate after post monsoon. All these things, cadmium concentration, SAR, sodium adsorption ratio. If it is more than 80, so this type of water is not suitable for the irrigation purpose. It directly. This is one case study. So the cadmium, chromium concentration. Second case study I want to discuss. If you are ready, there case study second because it is related to Aurangabad. Blue-green infrastructure. It is a new area where you can work, you can do your dissertation also. It's the best area. If you say, I can continue. Okay. So this is determine existing status of various blue-green infrastructure. What is the meaning of blue? Blue means river. Green means plantation. Blue-green infrastructure. So every person, human being, want to live nearby water or nearby garden. And if that type of condition is there, we purchase flat, we purchase a house in that area. If huge construction area is there, grace infrastructure is there, we try to avoid it. So we are nature loving people. Those want to live near to nature, so it is blue. But before 20 years, 2 decades, people try to live near river. But nowadays it is not possible because most of the river, most of the natural stream are coming with the wastewater. Because of that, it is giving bad effect. That is the existing condition. So to generate geomorphology map, drainage density map, groundwater potential map, environment map, water bodies map, blue-green spaces. Mr. Dr. Vikas sir has helped me for this project. So I prepared groundwater potential map. I use this methodology. Again, GIS. Here RGS 8.3. So here is the population of Aurangabad urban area. So this is my study area. Aurangabad urban area is divided into 9 zones. And total 132 wards are present in Aurangabad. These are zone 1, zone 2, zone 3, zone 4. So Kranti Chowk, zone 1. Okay, zone 2, zone 2 is Yan 64. Zone 3, Jaisinghpura. Zone 4, Harsul. Zone 5, Begampura. So in this way, total 132 wards are present. So this is map is prepared with the help of RGS 10.3. One my MTech student was working with me. So I prepared this map. So different courses of water tributary passing through the Aurangabad urban blue spaces. So here is stream 1, stream 2, stream 3, stream 4. So stream 1, 1,35,536 meter. Total 135 kilometer of first order stream. It's a natural stream. Natural stream. So because of plotting, Harsul area, so many urban area is they are doing NA44, NA45 plotting. All natural stream are dumped now. So these are stream 1. This map is prepared with help of RGS. With help of DAY map, we can have this type of natural stream. Stream 1, stream 2, stream 3, stream 4. Every smart city, smart village should have the map of blue spaces. Stream 1, 135, Stream 2, 69, Stream 3, 28, Stream 4, 7 km. So this is the Stream 4. This is red, calm river. And then our second, Suna river. So Aurangabad urban area is divided into two river basins. The calm river basin, another one is Suna. Suna is coming, passing through the Shenrai Madis. And calm passing through the this Panchaki. On the bank of this calm river, Panchaki is laid there. So this is first order. This is lakes are there. Harsul Lake, Sawangi Lake, then Valmi Lake. So blue spaces are present in urban area. Then Salim Ali Lake, it is spread in 1600 hectare. It is present in zone 3. Harsul Lake, 122 hectare, spread in 122 hectare. Sawangi Lake, University Lake. So I have prepared drainage map. In drainage, this is a drainage map of Aurangabad urban area. So here, drainage basin is natural unit draining runoff. Whatever the rainfall is falling in this area. So it is a natural drainage system. All this drainage system is damaged because of man-made activity. So here, lineament map. So this is lineament map. So it is very important map. So high density 1.4 to 2.17. If this type of density is found in that region, this region is susceptible for the contamination. The fractures are present. See, that means very important. In present study with very high lineament density 1.4 to 2.17, having good groundwater potential. So they can collect the water and groundwater get recharged. If contaminated water is there, again it will affect the groundwater. So this lineament map is very important map that will be helpful to find out the source of contamination. So this is a geomorphology map. It gives the details of reservoir area, discrete area, then water bodies area, this type of land use, land cover, very important map. LULC map, land use, land cover map, how much water bodies are there, how much agriculture land is present, barren land, vegetation cover, built up area, all this detail we can get details about the particular area by this map, land use, land cover map. This is 2000 map and this is 2021 map. Okay. So here, with help of land use, land cover, I found change detection. Agriculture land, what was the agriculture land condition in the year 2010? It was 8787 hectare. But in 2021, 8412, it is 8412. Near about 374 hectare is getting converted into built up area. So this type of study we can do with help of this GIS. Barren land, it was earlier 1136 hectare, reduced up to 213. This 923 will be get used for another activity. Built up area earlier it was 3583, it is increased 494. So in this way, whatever the increased area in built up area, it is directly affecting to the land use, land cover, directly affecting towards the blue green spaces in urban area. So this type of study we can do with the help of GIS DC. Okay. So this is about groundwater potential zone. So with the help of that, with the help of GIS, I prepared, with the help of my student, I prepared this map. Very poor zone. So red area, it gives indication that very poor zone is present in urban area and most of the wards. So each and every garden is covered by percolation dam, small farm pond. Each and every garden in Aurangabad, total 132 gardens are present, major and medium. And each and every garden is covered with the vegetative cover and some small ponds. Automatically, it will increase the groundwater recharge, and automatically it will reduce the domestic water demand, which is we are getting from the water supply system. So one research scientist told me that if community municipal corporation MGP will focus on or rainwater harvesting or storage of rainwater, automatically it will reduce the burden on water supply system. So this is the output of my presentation. Thank you. Is there any question? Type question.
Within time period only you have to tell the number.
So we have to maintain the 4 degree temperature. We have to collect the sample. We have to maintain 1 deciliter is there for 24 hours. You can keep there. We have to maintain that particular temperature. And after during sampling, we have to make titration method. We have to sample. We have to do sampling. 3 to 4 unknown we have to give. So 3 to 4 known we have to do known standards. So cadmium concentration it should be less than 0.03 mg per liter. So we have to prepare the standards. Then our unknown has to insert there. Then it will do the same. So in this way, AI is giving readings. So we have to prepare standards. So we have to use very precisely. Yes, that requires skill. Another question.
Any more questions? Okay, thank you, Shinde sir. We truly appreciate your efforts taken during this session. Now I declare this particular day to be over. There will be no sessions after this. We shall all gather tomorrow for our concluding day. Tea is available outside. Okay.